everybody. Welcome to another Hoss Talks Foss. I'm here with Rob Richardson, one of our speakers at Percona Live. Hi, Rob. How are you doing today?
I'm doing well. I'm great to be on the show. It's fun to be able to talk about all the things. The conference was really fun, and so it's cool to be able to revisit it now.
Yeah, and I don't know if have you attended Percona Lives in the past, or is this your first one?
This was my first Percona Live.
Okay. And, how did it go? Because typically it's, in person, but obviously with COVID, we've had to go online the last couple ones.
It worked. Online and in-person conferences are definitely different, and each have their strengths and weaknesses. But I think we're kind of getting the hang of doing online conferences, so I think it's working out pretty well so far.
Yes, I think it is. Now, Rob, maybe for the listeners here, give us a little bit about your background. Tell us a little bit about where you came from and what you do on a regular basis.
Yeah, definitely. I do a lot of programming, building websites, web properties for businesses small and large. And it's fun to be able to build that kind of content and really dig in and build solutions for users that are really interesting for them. I also like doing a whole lot of teaching. And so I'm a developer evangelist, developer advocate for Cyral. And that gives me the chance to speak at a bunch of conferences and to be able to teach really interesting things. So not only am I scaling my knowledge just to myself to one, but maybe I can scale it to 2 or 20 or 200. And that's really fun to be able to share and learn together and kind of ramp up our skills together, raise the ocean for everybody, as it will.
Yeah. And what kind of things are you teaching people now? Like, is there something interesting, a topic that you're really hot on at the moment?
It's really fun. When I got started, I loved drawing the short straw. Hey, we need to go figure out how to do this. And so as a web developer, my first task was, well, how do we deploy it? And so I intentionally drew the short straw, and I'm like, let me go figure out how to do IIS. How to configure Internet Information Services. Over time, that led to Windows Server Administration and in-time Linux administration. I drew the short straw again on purpose as we're looking at automation. How can we get DevOps going? So I first started with cruisecontrol.net. I've since done Jenkins and TeamCity and Visual Studio Team Services, and now Azure DevOps, and now GitHub Actions. Similarly, I drew the short straw when we came to unit testing, and I'm like, well, let me dig in. And so I have a really cool talk that talks about Cypress and how Cypress unit testing fits into the scheme of all the things. But I also do server-side testing, and I do unit testing. I have another talk that's all live demos of getting started with testing in JavaScript. Synchronous, asynchronous, promise, async and await testing. It's fun. And so what's really fun is that because I've intentionally tried to stretch myself, I end up with skills in all kinds of places. So I teach .NET and Node, React and Vue, dependency injection and version control, DevOps, server administration. I'm having a lot of fun with Kubernetes and Docker. I did a full-day Kubernetes workshop not too long ago, and it was fun to guide eager minds through this. One person actually in that workshop said, I've been using other people's containers for a good long time. I wish I had this a year ago so that I could have been helping and contributing to their Docker files. It was really fun.
Oh, that's awesome. That's awesome. And I think it's great when you can reach out and reach people who are eager to learn and teach them something new. That's a passion of mine as well. I love to talk with people and, to hear what stories they have and to help them, kind of move into the next story round. Now, For you, you mentioned testing, and testing something that I'm kind of a hot topic for me lately, because I've seen, especially in the database space, and a lot of people from a development perspective aren't testing their applications thoroughly enough. They're especially kind of forgoing some of the more integration testing, or even some of the scalability testing or load testing, and that tends to lead to problems. In fact, I talked with several users in the database space who have to deal with the operation side, and they go, it's those developers, they never test their code, that's why it's always broken. And I'm curious, having someone like yourself who teaches some of those frameworks and talks a lot about testing, what do you see in that space? Is there a lack of knowledge? Is there a lack of desire? Is it that developers just don't like to test? I mean, what leads to those?
Yeah, and what's interesting is that we see that kind of lack of interest in the industry where they're like, well, I need to get this task done. Management says, hey, we're not shipping tests, we're shipping production code, so why are you wasting your time on tests? Developers are like, well, I just need to get it done, let me just do it. And then we end up with content that is, well, less tested. Now, in some cases, that's totally fine. The purpose of testing is about risk mitigation. And so if the risk is low, then maybe not having tests was sufficient. And dealing with production outages when there's a crisis is completely sufficient, and that was worth the investment. On the other hand, we may want to reduce that risk. We may want to have some smoke tests, some integration tests. We may have a particularly hairy function, and we want to understand that this function works correctly in all of the scenarios that we're working with it. Taking a step back, we may have a piece of functionality, a microservice, or a unit of content, and we may want to validate that this works correctly. We can look at it from a UI perspective and say, I want to validate that this website or even this component works the way I expect. Or from the other side, the API, we may want to say, hey, I want to make sure that this API, given these inputs, creates this output. We could even do unit tests around databases to say, if I have this data in the table, that this stored procedure will run in an expected way, and that we validate the results in this way. So if it makes sense to reduce that risk, then unit tests can be a really elegant mechanism to be able to validate that. Now, a lot of people will say, hey, I've got these tests and it's really slowing me down. I would turn that on its head and say, a lot of the time that you're spending is debugging. You're ramping up your website, you're pushing all of the buttons to get back to this page, and then you're clicking the next button that you want to validate. And then you go change some code, you refresh it, you go click all of those buttons again. Wouldn't it be cool if you could have a mechanism for debugging by writing code? We really enjoy writing code. And so where the light bulb came on for me was debugging was my way of writing tests rather is my way of debugging by writing code. I can write code that is much more simple in all of the scenarios that I want to validate. Once I have those tests in place, then I can just push the go button, and for those that go green, I'm done debugging. For those that don't go green, now I can take a look and see what my function is doing. Maybe my test isn't correct, maybe my function doesn't validate. But then, have you ever gotten to the end of that scenario where you finally got this use case to work and you broke a different one? I just push run on the tests, and once this one goes green and all the rest of them go green, I know that my task is done. I've mitigated that risk. So in time, a quote from Jeremy Bites, I am actually faster by writing unit tests, because not only do I have that debugging by writing as code experience, but I also have confidence that all of the other scenarios that I tested yesterday or last week still work the way I expect. It's weird. It's like kind of counterintuitive to think that writing more code actually makes me faster. But the third time that I deploy and I caught an exception in the middle of writing unit tests that would have escaped into production, it's like, yeah, we mitigated that risk. Testing was really valuable in this case.
Now, that's really test-driven development, right? So you start with building those unit tests, you start with building out, what you want done in those tests, and then you code to it to make it green, like you said. And that's a philosophy that not everyone follows. Certainly it takes some getting used to, to start and, think tests first or test second, right up front. But I do think it does produce better code in the end because you have everything kind of thought out logically. So you almost go a little bit slower up front to go faster later on.
Right. It is about risk mitigation, and you don't get this for free. But when you get good at it, it is pretty fast. And whether you're writing the test first and then implementing the code, or you're writing the code and then implementing the tests right away, that methodology allows you to think more like the people who will consume your content. And so now you can build it in a way that makes sense for them. Granted, a test isn't necessarily a user, and so the closer you get to this, the more you may say, well, I want to really design for the user, not for the test. But it's wonderful to get outside yourself, get outside your code, and see that people will consume it, and to really facilitate them by thinking of them first. You'll also notice that as you build code that is easier to test, that your code will be more loosely coupled. You'll use more interfaces, you'll use more abstractions, you'll create this looser coupling between your components, which ultimately leads to a better design too.
Yeah, and I think one of the interesting things that we've seen, and your talk at Percona Live this year was about databases in the microservices world. As microservices have really taken off, and as we have developed more modern applications using more of a microservice architecture, the systems have gotten much more complex, which means that that integration testing between the different pieces becomes infinitely more important. I mean, how do you test something at scale when you potentially have, dozens of different microservices, dozens of different databases, all these different components that are sprawled all over the place?
Exactly. What's interesting about microservices is no longer can we do unit or even integration tests just solely around our microservice to prove our system works. We need that integration test between components to really make it work. What I like to do is build out some end-to-end tests. And by end-to-end, I mean, fire up the browser, click some buttons, get it to call all the APIs, get it to run through each of the microservices. Yeah, it's going to hit the database, and come back and validate that that works. And if we can build these end-to-end tests for the hot paths, the really critical paths, maybe we're doing a login, browse the shopping cart, add one product to the cart, get to the checkout screen. We're not entering a credit card number. We're not actually completing the purchase. But if I can get all the way from the home page to the checkout page successfully, then I know that my system will work and all of those crucial components will work too. Now let's rig that test to run in production once an hour. Now, as we're deploying these updated microservices, we can't necessarily test the entire system every time we deploy each test, but we can catch the integration pieces with this production test before our users start to get outages in their systems.
Now, Rob, what tools do you typically use to capture that workload and to set up those tests? Maybe give us a little bit of a walkthrough on that stack, so our listeners can understand what sort of tools you recommend, which aren't necessarily all the tools, but the ones you find most useful.
It really depends on what you're trying to test, and each test will have different requirements. For example, if we're trying to validate that this tax calculation works correctly, then we're probably writing unit tests and mocking out the dependencies. We'll need a mock library. If we're in JavaScript, we'll probably use... I just remembered the C# one. Let's back up and do the C# case first. So if we've got a C# function, we'll probably use MOQ or mocku to be able to mock out those dependencies. We'll probably use XUnit to be able to validate this function. If we're in JavaScript land, we'll probably use something like Mocha and with Chai or Jest to be able to validate that function. In time, when we're starting to up-level that, maybe we're looking at a component and we want to validate that this component behaves as expected. I click this button and this action happens, or it renders in this particular way. Now I'll probably use testutils together with my chosen framework. And so testutils is available for Angular, React, and Vue, and it gives me the ability to mount my component within a unit test, and then to run either Mocha with Chai or Jest around that component to validate it works correctly. Now, the cool part about testutils is I can choose either to mock out all of the child components or actually render them, depending on my needs. So that's how I would do a component test. Leveling up again, if I want to validate my API, I can just fire requests at it. I don't need a UI at all. So here I might use supertest, or I could even build tests in Postman. And that allows me to just fire requests at the API and validate that it works. When I'm ready to do end-to-end tests, all the way through all of the pieces, there's a bunch of tools. Selenium is the one that we usually reach for and then dismiss. I've chosen Cypress because I think Cypress is that great balance of deep interaction into the browser so the tests are no longer brittle or slow, together with a cool API that allows me to reach into all of the things. One of the things that Cypress does really well is wait for the request to finish. In Selenium, I have to set timeout. Was 2 seconds long enough? Well, that test failed. Let's make it 3 seconds. Well, now it's always going to wait 3 seconds. So even if it finished in 30 milliseconds, it's still going to wait 3 seconds. By comparison, Cypress allows me to loop into the browser events. So when DOM content loaded, now I can do the next step of my test. Or when this API call finished, now I can do the next step. Now I can definitely set the timeout and say, if you go longer than 5 seconds, call it a fail. But I can also proceed as fast as it's ready to go. So a Cypress test that is set up to run all of the pieces can run really fast and efficiently, just in the midst of running in the browser or running as part of a DevOps pipeline.
Very cool. Now, when before we move off of testing, I'm curious, are there common issues, or what are the most common problems that people make when they start building their tests out or trying to, test their code?
One of the first things that you'll hit is, how do I get started? How do I run one test? How do I get my tests into my DevOps pipeline? And the cool part is a lot of these tools now are really easy to get started with. I can just npm install the thing and it'll give me a command line. Maybe I add it to my package JSON, or I can maybe just call this straight from my DevOps pipeline. It's just another command line to put in my pipeline. Once I've got one test in place, now that's great. Maybe the test only just loads the home page and validates that I get an HTTP 200 status. The cool part then is the next thing that we'll hit is, well, how do we write the tests? And that's where you start to notice probably you have too tight a coupling between systems. It's difficult to mock out all these dependencies. That's really cool. You just learned something about your code. Now, refactoring all of that code to have looser coupling, to have less dependencies, to make it easier to test, that's kind of a long process. But for the new functions that you write, you can build them in a testable way, and you can just increase your unit tests. To get from 0 to 1 is pretty hard. To get from 1 to 2 is much easier. To get from 2 to 200 is just a matter of putting in the work to do that.
Oh, okay. So back to the microservices side, the talk at Percona Live was specifically talking about, databases in this space now. And as you had mentioned, a lot of different databases are used now across an organization. An application could have a dozen different microservices, and it could have a dozen different databases behind it. The technology isn't really tied to one single stack anymore. It's not like, everything must be a LAMP stack like in the old days, or, everything must be MySQL or Postgres. It's use the best tool for the job now. And that causes a lot of sprawl. So what are you seeing in that space?
Yeah, it does. And what's interesting is now we can optimize for the problem at hand. In the past, when we said, yeah, but I'd like to store a little bit of data here in Postgres, or this problem set best matches a document database, can I spin up Mongo? Then they'd say, well, you can use any database you want as long as it's here in SQL Server.
Yeah, and I think that...
Okay. So we would do all of these tricks to try and get our database of choice. Maybe it was SQL Server, maybe it was Oracle, maybe it even was Postgres. But we would do all of these tricks to try and get it to store the data that really made no sense. One of the principles of microservices is that each microservice owns its own data. And so one of the big things that I pull out in this talk is that because we have now lots of little data stores, they don't need to be the same vendor. We can go shopping for the vendor that best meets the needs of this problem. And the beautiful thing there is now we can have a little Postgres database and a little SQL Server database and a little Mongo database. And yeah, there is some administration involved in making all of those data stores work, but we can choose the correct one for the problem. Maybe the answer to this problem is an ELK stack or an S3 bucket, rather than a whole nother relational normalized schema.
Yeah, and I think that provides developers with an immense amount of flexibility to develop, their application quicker, to be able to get at what they actually need and ensure that they can utilize some of the built-in inherent efficiencies of each of the different databases. But it does cause, especially at scale, a bit more administrative overhead for those who are handling the back end. So as a former DBA, I know I call this the great inheritance problem. Like, hey, I'm an Oracle DBA, let's say, and now all of a sudden I've got Oracle, Mongo, Postgres, and Elastic that I now have to maintain. So it does push, the skill set, especially of the folks in the back end who are administrating that, a bit more. And I think this is where the benefit of some of the database as a service technology, some of the cloud providers provide, most of these databases as a service now, has allowed a lot of companies to move faster because they can choose what best fits them, and they can do it without having to worry about kind of that overhead of the back-end database administration, if you will. So it's definitely an interesting space now.
I completely agree. And that's where cloud vendors are really ideal in this space. Use database as a service. Outsource that piece so that you have one throat to choke and it's not yours. They'll take care of point-in-time recovery. They'll take care of the nearly 100% uptime. They'll take care of securing physical access and proximity, ensuring that your database is sharded correctly. You can outsource all of those pieces to your database vendor. And if your cloud provider provides that one-click provision your database, even better. Now you don't need to worry about managing all the things, and you can get back to doing the task that you need to do. The more automation you can put in place, the more you can make this problem easy. I've been on that team where, we started sprawling into different types of databases, and then it's like, oh, well, we had a problem in this database. Let's just go to last night's backup. We did back it up, right? Right? And it turns out we didn't. So as you start moving into lots of these databases, you do need that automation to make sure that your databases are backed up and that you have the authentication piece in place. If you can get automation to subscribe your databases to backup and authentication, now you can start to move at scale and get into lots of different database vendors and lots of different micro databases to be able to produce your microservices in really elegant mechanisms to keep that microservice owns its own database methodology in place.
Now, as we've seen, like, these applications kind of, evolve into these micro databases, microservices, this new architecture, it's kind of made a new problem, or maybe made an old problem a little bit more difficult, which is troubleshooting and optimizing and trying to find kind of that needle in the haystack. Because previously, when I worked, on a single monolithic, system, I would always get the call the database is slow because, let's be honest, everyone blamed the database first, and then, until you can prove it was something else.
Oh, of course.
But
my caching tier is broken, but it's the database that's
right.
slow. Yeah, that's the problem.
Yes. So how do you find which of those applications or which of those microservices are causing the issue and which components are there? As you have this really diverse, architecture now, it could be one of a dozen different components that has, maybe, different database, technologies underneath, and maybe even, like you mentioned, has slightly different caching as well. So what sort of, methods or processes can you find that problem that is occurring?
That's a good question. And trying to pick the correct cause is, quite a dilemma. The first thing that I'll do is I'll open up the Chrome developer tools, or maybe I'll use a tool like Fiddler or Postman to kind of proxy the requests between browser and server. And let me just watch the requests going back and forth. That can usually identify whether the problem is on the server side or on the client side. And not to say that blaming is the correct thing, but we can now start to focus in on the correct thing. Maybe the browser is caching the old results, and that's leading to the problem. Maybe it's not sending the authentication header, and that's the problem. Or maybe the request is just taking a really long time. Now that we've kind of identified whether it is a client or server concern, we can start to dig in. If it is a server concern, we now have a URL. And the beauty here is that we can fire that URL at the service a bazillion times until we find the answer. Probably given that URL, you can bring that back to a development environment and fire it off too. Now you may need to adjust for a different authentication token, a different URL, base URL, but you've kind of got a feel of where you're going. That will probably also tell you which microservice received the request too. At that point, now we can start to traverse the microservices. Here's where a tracing or logging platform can come in really handy. OpenTelemetry is a great piece that allows us to kind of visualize as requests move between microservices. Service meshes also do a really great job here, where it can kind of track the request as it moves through each of the services. Now, the cool thing about using either OpenTelemetry or Service Mesh is that you kind of get a holistic view of the entire system as you plug that into each system. With the Service Mesh, you just kind of plug it into Kubernetes, and it takes care of making all of the pieces in each microservice.
No.
With OpenTelemetry, you do need to hand it to each microservice. You do need to configure that service to expose the metrics. But once you've got that trace, now you can watch the request move through each of the microservices and maybe even see the SQL query that was created at the far end. Now you can time each piece and identify, oh, so here's the hot path. Well, that hot path, the one that gets executed a whole lot of times or takes the most time, now we can start to dig in. Is it a stored procedure querying against something that needs another index? Is it that our where clause is just humongous and ugly? At that point, now we can start to zoom in on that piece. Do we add caching? Do we add bigger hardware? Do we rewrite our query? Very specifically, we've used a whole lot of tools to be able to scientifically experiment with the system. Let's first identify client versus server. Then let's traverse that path and find where the majority of the time is taken. And then let's dig in to solve the problem that is actually broken. When we just start and say, your database is slow. Okay, you want me to push the turbo button again?
Oh, the turbo button. I miss the turbo button. Oh, back in the good old days of the 386s and 486s.
Every few weeks we just take out another thread.sleep and the system goes faster, right?
Well, Rob, let me ask you this final question here. And I always like to ask, something a little eclectic, that might be a little, out there. I'm curious if, as someone who goes out and tries to educate folks, is there something that if people could take away from this chat or take away from one of your presentations, just one thing they could learn and maybe change their habits, change what they're doing, try something new, what would that one thing be? Like, what would you say? Like, please learn this thing. Please do this thing differently. Please, try this new technology. What do you think?
What is the one thing that I would teach you?
Yes, coming out of this, like,
we're here on stage and we've been doing it for a while, but there is nothing magic about either you or I, or even the listener. There's nothing magic about you. We here have just been at it a little longer, but the skills that we have are completely attainable. You, the listener, the watcher, you can get to where we are and you can exceed us. The beauty of this path is it's just about learning and experimenting and doing. The next step is yours. You can go do wonderful things. You can go experiment with this technology. You can go find that passionate project that you want to do. You can have a lot of fun with technology. There is nothing that is unattainable about anything that we've talked about today or anything that you saw at the conference. You can take this step and you can be awesome. Go be awesome.
Thank you, Rob. Thank you for that. And, you can check out Rob's presentations and, his blogs at robrich.org, correct? robrich.org?
Yes.
Awesome. And Rob, thank you for...
grab me on Twitter at rob_rich, and let's continue the conversation. I'd love to see what I got wrong and how I can learn.
All right. And thank you very much, Rob, for hanging out with us for about a half an hour today, and also for presenting at Percona Live. We look forward to hearing from you in the future.
Most definitely. Thanks for having me at the conference. It was fun learning and teaching with you.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.